Hi, welcome back to Moose Chemistry. This is Chemical Equilibrium, KSP, KC, and KP, Lesson 1. Okay, the value of KSP of AgCl is 1.8 times 10 negative 10. What would be the molar concentration of Ag positive and Cl negative in pure water placed in contact with solid AgCl? Okay, so we go KSP equals Ag positive, and of course Cl negative. Okay, so we go 1.8 times 10 to the negative 10 equals x times x, right? So this would give me x squared equals 1.8 times 10 to the negative 10. Take the square root of both sides and you get x equals 0.0001346 molarity. All right, next problem. Given Kp 7.497 times 10 negative 12, N2 plus 3H2 yields 2NH3 in reversible reaction. What is the P of the NH3 if H2P is equal to 1.575 atmospheres and P N2 is equal to 2.15 atmospheres at equilibrium? All right, so what we're going to do is we're going to do this problem. Remember that Kp is just like Keq. It's products over reactants. So there's our product, and here are our reactants. All right, so Kp is equal to the pressure of NH3 square over the pressure of the nitrogen times the pressure of the hydrogen cubed. Now, where did the cube come from? From this 3 here. And where did the square come from? From this 2 right there. Just to give you an idea. So Kp, right, what is called Kp. So Kp is equal to, let's see here. We know the Kp. So let's make sure we do this right. Let's go ahead and write this. So the Kp is equal to, of course, 7.497 times 10 to the 12. So you go 7.497 times 10 to the negative 12 equals x squared because we don't know what that product's going to be yet, to 2 point, looks like pressure of the hydrogen is going to be, okay, so that's going to be 1.5 times 3. So the pressure of the nitrogen is going to be 2.15, so it's going to be 2.15 times 1.75 cubed. And after we work all that math out, we get that to be equal to x is equal to 9.29 times 10 to the negative 6. Atmospheres. Okay, let's look at the last problem. The last problem says, given N2 plus 3H in reversible reaction equals 2NH3 at 300 degrees Celsius and Kc is 3.0 times 10 to the negative 5th, what is Kp? Remember that Kp equals Kc RT delta N. All right, so now R is the universal gas constant, which is 0.0821 liters times atmospheres over moles times Kelvin, and delta N is the number of produced gas moles minus the number of reactant gas moles. Okay, So let's go ahead and do this. Oh, first thing we gotta do is we gotta take that 300 Celsius because we have to use Kelvin. Remember that we're using Kelvin in this formula here, right? So we have to go Kelvin equals C plus 273.15. So K equals 300 plus 273.15. So K is equal to 573.15 K. Easy enough. All right, so now we've got that. And we know that our delta N is going to be equal to 2 minus 4 equals negative 2. All right, and how do we determine that? Well, there's a 1 in here and a 3 that gives us a 4, and this is our 2, so it's produced moles, that's 2 right here, minus the combined right here is 4, gives us this negative 2. Okay, so now we're ready to do the problem. Okay, so we know our Kc value, which was given to us, which is 3.0 times 10 to the negative 5th. So we go Kc is equal to 3.0 times 10 to the negative 5th. So let's go ahead and set the problem up. So our equation is going to be Kp equals our Kc value, which is 3.0 times 10 to the negative 5, times our R value, which is 0.0821, right? Liters times atmospheres over moles times Kelvin, times our temperature, which is 573.15 K to the negative 2 power. All right. So now we're going to multiply these two together right there, right? So this is going to give me a final value after you do the math. It's going to give me 7.49 times 10 to the 12. Is it going to be the 12th or the negative 12th? It looks like negative 12. It's going to be negative 12, I believe. Let me double check my math here real quickly. Let's see here. 0.0821 times 573.15. Okay. And then we're going to go, let's see here, raise that to the negative 2 power. Exponential, we'll square that, 47.5. And we'll square it to the, okay, and then we're going to times that by 3.0 exponential negative 5. Okay. All right. So we're going to get, it looks like, let's see here. I'm going to double check my answer here. So I get 3.0, right, 3.0 exponential negative 5 times 2.499 exponential negative 7. Yep, 7.49 times 10 to the negative 12. Got it right. It's always good to double check your numbers. Well, that's it for this lesson, guys. You be snarly. I will see you back here at Moosine Chemistry.